Hi, in this video we'll walk through a real-life use case to understand how a gateway project works. In API Gateway 2.0, we can create two types of projects, named gateway projects and proxy projects. You will also learn how an existing pathway application can be exposed as a REST API using the newly developed API Gateway 2.0 UI. Before we begin the demo, let me briefly introduce the backend services involved, the payment service and the fraud check service. Both services read input data from $receive and the data exchange format uses DDL. The payment service receives requests from requesters running on Nonstop and then internally invokes the fraud check service using the paths in API. Our goal is to expose the payment services as a REST API, enabling it to be accessed from external platforms. The Nonstop API gateway serves as a bridge between these external clients and the payment service. It accepts HTTP, HTTPS requests with the JSON payload, transforms a JSON into DDL format, and then invokes payment service. The response from the payment service is converted back into JSON and returned to the client. Importantly, no configuration or code changes are required in the payment service to achieve this integration. To access the UI, the API Gateway Manager must be up and running. This is a landing page you will see upon accessing in the UI. To build a REST API or any integration, you must first create a new project. Enter all the required details such as the project name, description, ID, and type, and then click Save. This action generates all the necessary configuration files with default values populated. Clicking on the project name takes you to the designer page. The generated configuration files are listed under the Files tab. The container underscore config.yml file contains all the configuration details related to the API Gateway runtime, such as HTTP or HTTPS ports. You can modify the default values in this file as needed. The Nonstop API Gateway will be deployed in a pathway environment. Its specific configurations are found runtime underscore tsmp.yaml, while container underscore config.yml, runtime underscore tsmp.yaml are related to runtime configuration. The actual integration logic resides in integration.caml.yaml. Click integration.caml.yaml to open Workflow Designer page where you can orchestrate workflows and expose them as REST APIs. To complete the integration, a workflow must be created. Based on your requirements, you can use camel components, camlets, and well-known integration patterns to build the workflow. Here, we will route incoming requests to a pathway application. Therefore, we will select Invoke DDL, TSMP service camlets, and fill in all required parameters such as pathman name, where the payment service is running, and the server class name. Since the service uses DDL, the API Gateway Manager must understand the DDL definition. To transform JSON into DDL format, first import the DDL definition into DDL registry. Then select the appropriate DDL definition for both the request and the response. Now that the workflow is built and routes incoming data to the backend service, we need to expose it to external clients. Workflows can be exposed either as REST APIs or Kafka consumers. Here, we'll focus on REST APIs. Create the service and configuration. Specify the URI and HTTP method. REST APIs can be secured using various mechanisms. In this example, we have used OAuth 2, which has already been configured. With the API design complete, the next step is to build it. This creates an image that includes the runtime configuration. Images can be tagged, allowing multiple builds with different configurations. The generated image must be deployed to start the API gateway runtime. The environment can be stopped and restarted as needed using start and stop buttons. If any changes are made to the project, then it must be rebuilt and redeployed. The dashboard is currently rudimentary, showing the number of processes. It will be enhanced with more capabilities in future releases. In the logs tab, you can view all the log files generated by the project. You can preview any log directly from the interface or download it if you want to analyze it locally. Now that the API gateway is up and running, let's send some requests to it. We use the Postman utility to send HTTP requests. It is configured to obtain a token from the OAuth 2 server and include it in the request. This is an input request in JSON format. OpenAPI documentation for the REST API is also generated automatically. That is all for this demonstration. Thanks for watching.